So this is the first part of the video. In this video I'll show you how to program your drone using Betaflight. So for this you'll first need to download Betaflight. Type Betaflight, download GitHub. Click on this, scroll down and choose your file. So this is for 32-bit Windows system, this is for Android, this is for Linux, this is for Mac. So we'll choose the Windows, click on it. It will download the installer. I won't do it since I have Betaflight. You can just follow this follow the steps for Betaflight and select all the positive responses like yes and download. Then we go over to Betaflight. Then we take our drone, and in our flight controller there will be a USB port. If you have built it exactly like me, it will be on your right side. Plug it in and connect the USB to a free USB port. And before you do anything, I would like you to go into this settings option, click on permanently enable expert mode and select reopen last tab on connect. I also like to keep the back theme on, or else you can also keep it off if you don't like it. Then if you're unable to connect, it's over here it says fail to connect to COM port. Then what you need to do is download these drivers. So you need to download these STM USB 32 drivers, and if it still does not work, you need to download these ZDX drivers. And for some older flight controllers, you might need to download CP210X drivers. I have already downloaded all of them, and there are many videos on YouTube which show you how to do it, so I won't cover that in this video. So first, before even we connect, we'll go to firmware flasher. If you already have some data on your flight controller, like you're using it from another quad, click on connect, click on CLI, then type diff all. It auto completes it for you, then press enter. There will be a lot of text which appears here. Go to firmware flasher, select your target board. So originally it will look like this. Choose a board, choose a firmware version. So if you don't know which board you are using, click connect, go to CLI and write version. Here it says it is a Xylo F4. So we can disconnect, go to firmware flasher, and these are alphabetically arranged. We go to X. So here you have it, Xylo F4. Then you can choose the latest version. In this case it is 4.2.9. Click on it, click on no reboot sequence and full chip erase. Then click on load firmware online. Then click on flash firmware. I am not doing it because I have already finished this quad. If you click on flash firmware, it should start flashing the firmware. If it is unable to flash the firmware but it was able to connect, you might need to download ZDX drivers. Then once you have done that, click on connect. First thing, when you open Betaflight 4.2 and above, it will ask you to apply custom defaults. Just say yes to that. I won't explain what it does. If you don't say yes to that, you'll need to reflash your board. By the way, this process which we just did right now was known as flashing. Before this process, the firmware flasher is known as flashing. Then after that, keep your drone on an extremely level surface. Then click on calibrate accelerometer. Then go to your ports tab. First of all, never disable this USB VCP configurator MSP. If you do this, it is very hard to make it work again. Betaflight won't connect. So these are the UARTs. These are basically the things which allow our components to talk to the flight controller. You can take these as a USB port on your computer. So since you can't put many things on a USB port, you can only put one. So you will only select one in each of these. So for example, in USB VCP, configuration MSP is selected. So we will deselect everything else in this row. In UART 1, we have serial RX selected. So we will disable everything else in this row. Then in UART 2, we have nothing, it's a free UART. Same with UART 3 and 4. Then in UART 5, in the peripherals, we have the VTX TVS Smart Audio. This is what allows us to change our VTX's channels and everything. If you're using IRC tram, you will click on this one. How you will know which one you're using? the answer to this is you'll check the product page, search for it in just type smart audio. If it is nothing comes up, type IRC tramp. One of those will come up and it will show you. Then click on save and reboot. Don't forget to click on save and reboot after every change, after changing every page. It will auto connect you if you have this reopen last tab on connect enabled. Then we go to configuration. This is where we do the majority of things. Make sure quad X is selected and nothing else. Then I am running reverse motor direction. If you don't want to run it, it's your choice. So in default motor direction, the motors will spin towards the camera and towards the back of the drone. But I have reversed the motor direction. This is so that the dirt does not come into the camera. This is also so that if I collide into an obstacle, it just pushes me back instead of sucking the drone in. So in this, they move away from the camera and away from the back of the drone into the sides. Then in this, we'll select D-Shot 300. And we could select D-Shot 600, but there's a reason why we are selecting D-Shot 300. It is because we'll enable bi-directional D-Shot. This can only be done in VLLE 32 firmwares, and I think for VLLE ESCs you need to flash JESC or some other firmware on it. Joshua Bardwell has a video on it. Since I am using a VLLE 32 ESC, I can turn on bi-directional D-Shot. Then if you have built the exact same drone as me, you need to count the motor poles on your magnet. I'll tell you, for these motors it is 14, and if you have some other motors, you'll need to count how many magnets are there inside the motor. You might also be able to find it on the product page. Then this is the motor idle throttle value. So for example, your throttle is from 0 to 100%. So when you arm your quad, it will spin at 5.5% power if you don't give any input to it. Then if you have built your drone just like me, you don't need to do anything in the board and sensor alignment. But if say you have put your USB on the left side instead of the right by mistake, you can change these to correct the orientation of your drone. If you don't change these and you have a different orientation, you might have a problem in which your drone will spin out whenever you try to take it off. Then system configuration will turn on accelerometer, turn off barometer and magnetometer. Then gyro update frequency is locked at 8K and betaflight 4.2 and above. We don't need to change that. Then select the PID loop frequency to 4 kHz. We could run this at 8 kHz, but we should, for the PID loop frequency, it should be a constant frequency. At 8 kHz we might see drops, and we don't want that. So it is better to keep it at 4 kHz. Also, the higher in the kilohertz we go, the harder it is to tune your quad. Then in this you need to select the maximum arming angle to 180 degrees. I think by default it is 27 or 25 degrees or something, but this is an important safety feature. This feature does not if it is on 25, it does not let you arm if your quad is tilted more than 25 degrees. So say you keep moving, you're taking your quad in your hand and accidentally hit the arm button, you can arm it in your hand itself. So this will prevent it, but setting it to 180 degrees will disable that functionality, but it will help us arm in turtle mode. Say you flipped over in your crash, and now you want to reverse your motor direction and flip it back. You can do that with D-Shot, and for that you need your arming angle to 180 degrees. Personalization, you can leave this alone. Camera, you don't need to touch it. Then in receiver, select serial based receiver if you're using the FrSky, but if you're using FlySky receivers, you'll need to select iBus in here. But since I am using FrSky, I'll select SBus. This is PWM, and most of you won't be using MSP and SPI, and this is PPM. But serial based is digital, and it is also better and has a lower latency, so I put that in this drone. If you're using a PPM receiver, you can select this one, and if you're using a PWM receiver, which you really should not use in these days, you can select this one. Then click on SBus for the FrSky. Then leave all this alone. In this you need to turn on display, air mode, OSD and dynamic notch filter. Then in this, go to D-Shot beacon configuration, then beacon tone to 1, RX lost and RX set. Turn both of these on. Then turn all of these on. They should be on by default, but if they're not, just turn them all on. Then next go to your power and battery tab. Set the minimum cell voltage to 3.3, maximum to 4.2, warning cell voltage to 3.6. Hit save. Then what you'll need to do is connect a battery into your drone. Before you do that, take a multimeter which you know is accurate, measure the entire battery voltage, then plug it in. Once you plug it in, you'll get a voltage in this. It might be different from what you are seeing here. I'll just connect a battery and show it to you. So right now I'll connect a battery and just look over here or over here. Also, you need to keep your propellers off in this entire process, or else you can seriously hurt yourself. It says 12.5 volts and I just checked with the multimeter, it is saying 12.5 volts. But say it was reading a different number like 11 volts or something. Then you will use the scale, divider value and multiplier value to change it. So you can think of the multiplier value as a roughest adjustment, divider value as a final adjustment and the scale as the finest adjustment. Say I put the multiplier value to 2, hit save, now it says 6.3 volts. But if I put the divider value to 11, instead of 12.5 it says 11.4 volts. So you can see that is the lesser increment or decrement. Then if I put the scale up, it is a very tiny increment or decrement. And for the amperage meter, the best way I have found to do is take a fully charged battery, put it on a drone, fly it for however long it lasts. Then before you disconnect the battery, just read the final milliamp hours drawn. Then take the milliamp hours and put the same battery into the charger without connecting it to anything else. Charge it up and you'll see how many milliamps the cell has, this charger has put in. And then you use the formula which I'll display on the screen right here, and you use this formula, put in the values, and then you'll get a scale value. Put the offset to 0 before doing any of this and before even going for flying. Then put the value you got, scale value. For me it was 202, for you it might be different, so just don't copy these values. Then once you're done with all that, you will have a calibrated battery meter and voltage meter. If you want your voltage meter to be really calibrated, you can do this multiple times. The more times you do it, the more calibrated it will become, but I just did it one time because I don't look at the amperage when I fly. Save it, go to failsafe. You don't need to do anything in this, don't touch it. Go to pit tuning. This is where you can put in your custom pits. So, for example, you're building a quad and you're building the exact same quad someone else has built, and they found out pits which were better than the default pits. So you can take those pits and put them here. Then in this you get filter settings. Don't touch these unless you know what you're doing, these filters, because if you put them all the way to the right, you can cause a flyaway if you have too much vibration in your quad or you have bad propellers on it. So don't touch these, leave them default. If you're a beginner, if you know what you're doing, feel free to put them all the way to wherever you want. Then remember, we turn on our RPM filtering, so we'll need to go to dynamic notch filter, set the dynamic notch filter width % to 0, dynamic notch Q to 250, dynamic notch minimum hertz to 70, and dynamic notch maximum hertz to 350. I won't explain what all of these do, but because this is a very detailed topic, you can read the GitHub page of the Betaflight developers if you want to know what they are meaning from this, or you could also see some videos on YouTube. Then this is your receiver. Once you have connected your transmitter to your receiver and you turn on your transmitter, you should see movement in this. I'll just connect my transmitter and show you how this works. Now in some drones, you might not be able to power your receiver directly from the USB. Luckily in the one we are making, you will be able to do it easily. So I'll just turn on my transmitter.
Welcome to OpenTX.
Now see, immediately all the values changed as soon as I connected. For this you need to be bound to your receiver needs to be bound to your transmitter. If it is not, you will not see any change when you move your sticks. since mine is bound, I was easily able to connect it. There are many videos on YouTube and also FrSky's website on how to bind it. And if you still don't know, you just need to hold down the bind button and put your transmitter in bind mode and connect it. I've already made a video to show if both of the lights are green and both of the green and red lights are solid, what you need to do. You need to change the firmware. You can refer to my previous video for that. But now we need to check something. So here's something we need to check. If we do the roll stick, which is the right stick, if you push it from left to right, we should see the topmost roll stick moving, and you can also see it in the 3D diagram over here. It is rolling. But say if it is not rolling but pitching or something else, then you need to select a channel map. So this is basically, you can select FrSky, Futaba, High-Tech, or try any one of these three. They should work. So this is TAER. So our first channel is throttle, second is aileron, third is elevator, fourth is rudder. And then you'll also need, I'll show you how to configure these switches, but you need an aux2, an aux1 and an aux3 for this. I'll show you now how to do the things in your transmitter. In your transmitter, firstly click on menu, click on page. This gets model setup. This is where you can type the name of your drone. I've already done that, so you can just change the letters like this and hold them to put them in caps. And you can do this for all of them. So I'll just change it back to what it was. Hit exit. Then you need to go down, or you can go up because way down there. So just click up. Then you go to receiver number. So first of all, you need to select access D16 mode. There is access ACCSP D16 LR12 in the new access. Select ACCSP D16 channel 1 to select 8. Channel 1 to it will be lower latency and for work 8 channels already. Receiver number 1 and click on bind. Then on failsafe mode, click on no pulses. After all that is done, click page, page, page. Say you go one page ahead of where you want to go, hold the page and you'll go one page back. So click on page, get to the mixer screen. Then go all the way down to, you'll only see 4 channels in this at first. Click on the 5th channel. I'll just show you how to do it with a different channel. So click on the channel. No need to touch the mix name. Click on source and pull the switch you want. For example, this one. So I'll pull it and then I'll click on exit. But since I've already pulled it, I won't touch anything in this. So I just delete this. Then you hit page to the output screen, and this is where we need to go to the computer, and I'll show you how to calibrate it. So now we have set up all of our aux modes, and now what we need to do is we need to calibrate our transmitter. So we can't change those values randomly. So what you need to do is pull your transmitter stick all the way to the left lightly. Don't pull it hard. Then go see this. You won't be getting exactly 1000 most probably. Then you need to tweak those minimum and maximum values so that it matches. So I'll just put it out of sync just to show you how it happens. So if I've pulled it all the way to the left, it says 1000. But see, you can change this using your transmitter. Also, if you are unable to get the right value you want, you can go and click on enable extended limits. In the page where we bound our transmitter, just scroll there, you'll see enable extended limits. Turn that on if you are unable to connect. If you are unable to do this to exactly 1000 and 2000. Then if you have done it exactly 2000 and it stays at 1500, you can change the stick low threshold to 1010, stick center to 1500, stick high threshold to 1990. So these are basically the lower threshold should be a bit higher than the lowest, and the stick high threshold should be a bit lower than the highest, so it should make a space in between. Then we click on save, go to the modes tab. In this, click on arm, then you'll need to click on add range here. Then pull your aux 1 and you'll see it moving. So say you want it armed, when you push it down and move the slider over to where you want it. Right now it says arm disabled because we are connected to USB. Then click on angle and select a switch to how you want it. I did it like this, and now I'll select the range to how I want it. Then the same for beeper. So we are using a preamp switch, which is the there's only one momentary switch on this version of my transmitter. So this I'm using that for the beeper as well as the preamp. So on beeper we just pull it down and we take it to where we want it. So if say you crash and you pull this switch, temporary switch, it will start beeping. The motors will start beeping. Go down, then click on flip over after crash. Then what you do is select how you want it and add the range like the others. Then for preamp, I have put it on the same aux as the beeper. So you can do this, there's no harm in this. Then I pull it and put it to how I want it. Hit save, go to adjustment, go to motors. So this is where you should have your propellers off. Convert me, because this can really hurt you, because we'll be disabling our functionality that it won't arm in USB, and if you have your propellers on, you can seriously hurt yourself or even your surroundings. Many people, these motors are powerful enough to cut your fingers and even your hands, so don't take any risks. Take off all of your propellers, and if you're following this guide how I'm telling you, you should not even have put on your propellers right now. I won't be doing this right now because I have propellers, so I've even disconnected the battery, but I'll just tell you how to do it. Click on I understand the risk, the propellers are removed. Click on master, then start pushing the up arrow key. As you can see right here, this number is rising. So the more this rises, the faster your motors will spin. Whenever you are testing this, so the first thing we need to test in this is our motor direction and our labeling of the motors. So first of all, put this up so the motor starts spinning. Then you need to touch the motors individually. This is why we need to have the propellers off and see the motor direction. So the bottom right motor should spin counterclockwise, number 2 should spin clockwise, 3 clockwise and 4 counterclockwise. So this is the reverse direction. If you have the normal, all of these will change. So the first motor will be clockwise, then this would be counterclockwise and clockwise. So you need to check that every time. But then you need to check your motors. So say I turn on motor 1 and it spins motor 4. There are many videos how to fix motor mapping. I won't be covering that in this video, and if you have followed along with my guide, you should not need to do change the motor mapping. But say your motor direction is reversed and you need to fix it. The best way to do it is to go to your BLE suite, click on BLE suite 32, turn it on, hit connect. But you won't be able to connect unless you have betaflight on. So you need to turn off betaflight, then hit connect. Then click on the ESCs you want to change the motor directions in. So for example, this is ESC 1. So here you have it, motor direction, normal and reversed. Change that, then click on flash VL, then click on right setup once you have changed it. Then at the end, you can go to your motors tab over here, click on I understand the risks and turn up each motor and see how it performs. Then we go ahead and open betaflight again, hit connect. Then we go to our OSD. This is customizable, you need to set it up how you like it. So I have the low voltage and all the warnings in the middle. The battery voltage at the top, right here, current here, angle mode, and this shows the mode which we are currently in. So for example, angle mode, air mode, So this shows that. Then we have a milliamps drawn and a flight time in minutes. How you turn on all of these? You need to click on this one, battery average cell voltage. I am using the average cell voltage because it is easy to interpret if you are using different batteries. So this is all you need to turn on if you need to copy my OSD. Turn on warnings, and in warnings click on arming disabled battery critical, battery not full. You can turn this off if you don't like it, and just do all of these. Just turn off core temperature because it will keep sometimes say core temperature too high. You don't need to worry about that. Turn off that and rest, leave it all on. Click on save. Then we need to go to video transmitter, and once you turn it on, it won't look like this. Go to this page, click on this icon, it will take you to this page. Then go down, TBS Smart Audio. Then you click on this one, the USA version. Copy all of this, press Ctrl A, then press Ctrl C. Go to your betaflight and click on load from file. I have already done that, so I won't do it here. Then you can just turn on your goggles and see which one. If say you put it to race band 1 and the power to 600 milliwatts, then you should change your goggles to race band 1 and it should be there. This will only work if you have a battery connected. So it puts the device ready no if you don't have a battery connected. Then we'll go to pit tuning, and this is something you need to go to pit profile settings. Click the profile one, change the scale factor to 100 and cell count to 4. Hit save. Then go to pit profile 2. Change the scale factor to 70 and the cell count to 6. I'll just put up a formula here which shows how to calculate your scale factor. What this will allow us to do is if we plug in a 4 cell, it should keep the rates for a 4 cell battery. But if we plug in a 6 cell, it will automatically change the rates and limit our throttle by the scale factor to 70% of its original power, and therefore we will be able to fly 6 cell on one quad only. That's all you need to do in this. Click on save, go out of there, then hit disconnect. So you're done with your betaflight programming. Congratulations. Now we can go out and fly our drone. So in the next video I'll be showing you how to fly your drone. The next video comes out next Sunday at 3 PM. Be sure to watch that video to see how it flew. And there'll also be some tips on how to do your first flight, because during your first flight you need to be very careful as anything could happen. You could have it fall out of the sky, flip over, or fail safe. Also make sure that your failsafe is set to no pulses. If it is not and you lose if you lose connection, your drone will not even come down, it will just fly away on full power. So it is one of the most important things in the drone. You need to keep it on and keep it on no pulses. Keeping it on no pulses means that it will the flight controller will do nothing and let the receiver do it, and the receiver will automatically tell the motors to cool down and disarm. Then it will start beeping so you can find it.